Last time we started surface area. And the cool idea was that we're gonna are you guys ready? That we're gonna put tiny parallelograms like this on top of surface everywhere. They are flat, so it's not like we're bending them, and the surface is bended, but it's a good approximation. And the tinier they are, the more they match your, like imagine this is epithelium of your skin, right? The cells, skin cells. I mean, they are also kind of flat, and the tinier they are, the more they're covering the skin. So it makes sense. But the cool thing is we know how to find area of parallelogram, and we're using derivatives and then cross product of those derivatives. So slope, tangent line, cross product gives you area. We learned that formula for the first exam. Something is flying. We learned that formula like second week of classes. Maybe, oh no, it was cross product. So probably third week of classes. And now it comes back because cross product is extremely important. Okay, so that was pretty cool idea that we're covering it. Like I told you, it's always in engineering and physics and math, is the idea is we're using objects we know to approximate objects we don't know. How cool is that we're dividing everything in sectors? In computer science, when they code, and we talked about this beautiful shape called helicoid. Look at that. In computer science, when they code, they also divide everything in segments. Sometimes are triangles, sometimes not. And then if the character steps in this segment, turn left, steps in this one, shine up. Or if you know those computer games when you need to touch things, search and find, right? When you need to find objects really fast. They also divide it in sectors, and then when you touch with your finger anywhere around here, you get the points. So it's literally the same idea in coding, and it's pretty cool. Let's do one more example. The problem is I gave you two formulas. One formula is good, another formula is so-so. The good formula, integral is empty, there's no function here. And then ds, so let me show you again. Empty integral, and then a ds, that's the tail called ds, was absolute value, which is magnitude. So let me put 2. Of what? Cross product of, to create parallelogram, cross product of two vectors, but not just any vectors. They have to be very close, hugging the surface. To hug the surface, that means partial derivatives. And then du, dv. So it is an empty integral. There's no function inside. We're going to actually change that later in the next section. That's what creates a surface. But then the second formula was like that. If you have a function given as z equals blah, 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 there's a shortcut for that. It is faster, but now you have to remember one more formula. You don't have to. If you do the old way, you just have to calculate cross product. In this case, you don't have to calculate cross product. Then the answer will be the same. So let's do one more example from your homework. As you can, it's literally from your homework. Find the surface area of the part of the sphere that lies above the cone. That's ice cream cone. Something is above of the cone, and that something is some part of the sphere, not necessarily half, by the way. Just think about that. Some kind of part of the sphere. So that's how ice cream looks like. Oh, I wanted to tell you an anecdote. Let's not forget, like in 20 minutes, I'll tell you a funny and maybe sad anecdote. Yeah, it has mixed feelings. So I can show you how to draw the picture. We first draw a cone. A cone, by the way, has both sides, positive and negative. That's for you to know. Many people don't remember that cone has plus and minus. But do you know how I know that we only need the classic upper half of the cone? Do you know? Not necessary. Look at the equations. So write down the equation. X squared plus y squared plus z squared equals 16. That's a sphere. It lies above the cone. Z equals square root of x squared plus y squared. Yes?
You're only talking about the positive square root of x squared plus y squared.
Exactly. Good job, both people. And anyone else who thought about that. Z have to be positive or 0. So that's how I know. If it is not the case, then we have to assume both. So now I know I have only upper half of the cone, and it's infinite, right? It's keep growing. But then there's a sphere that's centered at 0, 0. So here it is. Let me draw x, y, z. This sphere is, I don't know, like centered at 0, 0, right? And then we need only this top of the ice cream part. Not necessarily half or quarter or third, but they do intersect. Why it's not above like that? Well, actually, they do intersect. That's given. So it can be even bigger if you want. Then this is the intersection. But this is my drawing. So this is how I would see it. The beautiful picture tells you the result. So they want us to find surface area of this object. Basically, how much space this ice cream cone will take in the fridge. You don't have to have volume because you don't care what's inside when it takes space. Surface area can tell you how much space it takes physically, for example. And it's just example, I guess. And this time we can use this formula, which is the second formula. It will be faster this way. Let me show you steps. So write down this formula again to review. You just missed the song, the fat ass drop. Oh, now it's in my recording. Oops. Too late. And there's lots of weird stuff in my recordings. If you ever listen carefully, I'm trying my best not to put anything weird, not to say anything weird, but it's hard. When you're a little bit weird person, it's hard to control your weirdness. So let me show you steps. Remember the steps? I try to teach you steps in case you freak out during the exam, then you know what to do. So the steps here, what did I say last time? We should do step 1. Remember? If we're talking about slopes, then the step 1 is pretty obvious. For slopes, we take derivatives. So the moment you know we have to work with surface area, that means we have to work with slopes. That means, can't find it. We need to start with taking derivatives. So, solution. First of all, what is my z? So, if I have z equals blah, 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 then step 1 will be find derivative of that z with respect to x, find derivative z with respect to y, because that's what in the formula, it's f and z is the same thing in this case. So z is a function of x comma y. 2 inputs, 2-dimensional inputs and 3-dimensional output, right? So I'm not sure what my z is. What z are we going to use? Because technically speaking, we can solve for any. So what we're going to do, because I can solve for this z and this z. So what do you think then I should do? Which one should I choose? Guess. First one, then we're only going to find surface area of the ice cream piece. The second one, and we're only going to find the area of the cone. To have both at the same time, let's find intersection. And I'm not talking about points in this case. I'm talking about plug one inside of the other one, right? That makes sense. So if I have z equals, step 1, let's find z. Z equals a square root, where was it? Z equals a square root of x squared plus y squared. Z equals a square root of 16 minus x squared minus y squared. Here they are together. So the function, actually I just realized I know what you were saying. Can you justify, then it will be nice. Can you justify why do you think we should use the first one? What do you think?
I mean, if you find the first one, you can plug them into one another and find where your bounds are.
Yes, exactly. I was trying to do the second way, and then I realized your way is better. So we're gonna do it this way. I was trying to find it in your homework to show you, but it's fine. Now we know this, so from here we can find where do they intersect. Let's do that. The square root, let me zoom in. The square root of x squared plus y squared equals the square, or you could just plug z into z. That would be smarter, to be honest, but it's okay. Minus x squared minus y squared. Then, remembering that it was positive, so we don't need the negative part of the cone, it will be x squared plus y squared equals 16 minus x squared minus y squared. Moving everything to one side, we'll have 2x squared plus 2y squared equals to 16, dividing by 2. X squared plus y squared equals to 8. This new equation represents their intersection. So that is where they touch. Intersection. That will be the biggest part of the projection on the xy plane. So it's going to be that shadow, the biggest circle. Let me show you on a circle, on a picture again. So how big all this object is going? This big as this biggest side. The cones keep growing and the spheres keep decaying. So the biggest circle we're going to have will be this curve C. And the curve C we just found is x squared plus y squared equals 8. Do you agree? Why do we need it? That will go into double integral area. What is this domain we're talking about? Domain is the shadow on the xy plane. Projection. I call it shadow, but professional way to call it is projection. So now we have this D. The D is that circle. So let me show you. This domain D, oh, it says that. Domain D. So write down, the shadow is your domain D. Curve projected on the xy plane. So I'm checking the formula. I have my D, the function inside. Gonna go by the definition. Let me show you again the formula. Here it is. Actually, I have a nice explanation of all the variables this time. Surface area. Surface is given by. So whatever is putting it down, we're going to be using the square root of 16 minus x squared minus y squared to take our derivatives with respect to x and with respect to y. So let's do that. So that gave us domain. Let's see. That is domain D. This circle. Not just a circle. It's a circle centered at 0, radius squared of 8. Step 2. Z equals s square root 16 minus x squared minus y squared. We're going to find derivatives. That is my f. So z with respect to x and z with respect to y. Before we did it z with respect to u and v, but you can always rename it, doesn't matter. So, and also, bless you, the parameter here is not needed. It's already given really nicely. It's kind of the same idea of with x and y being u and v, just like, don't have to be bothered. So that's supposed to remind you what chain rule is. 1/2 goes down, copy to the negative 1/2, 16 minus x squared minus y squared. That will be the same for both. The beginning is the same. That's chain rule. Times the derivative of the function inside. And that's when you know it matters with respect to what to differentiate. 16 minus x squared minus y squared with respect to x gives you negative 2x. And then the other one is negative 2y. Amazing. So that's basically the whole difference. We have that. Instead of finding, and that's basically the difference right now. Before we would find cross product. Yeah, we're not going to do it right now anymore. That is good enough. The formula tells me, I keep staring at the formula right now. This is the formula says, the square root of 1 plus derivative squared plus derivative squared. Yeah, good enough. See, this is the one with the z with respect to x and z with respect to y squared. So this is a shortcut. Step 3. The formula, let me put it in purple. Area of S, surface area. Double integral over d, which is a circle, x squared plus y squared equals 8. Well, actually, it's not a circle. See, I should not say that. Do you know why it's not a circle? I should be more careful with those little things. Equals 8, it is circle, but are we actually talking about circle or no? Circle and disk is not the same thing. Just like, so circle is only this edge, but if I'm talking about the whole shade or shadow, then it's not equal to 8. It is what? Less or equal. That's called a disk. It's just the circle gave me what's the biggest size of the disk. Because we have many disks. If you look at this side, it will be this projection, this projection. That's what contour maps are. But we have the biggest one, 8. So with the radius squared of 8. So I would say, write down, it is a disk x squared plus y squared less or equal than 8, like so. So that's my D. Let me finish writing and then I'll ask for questions. A huge square root. 1 plus derivative squared plus derivative squared, and then we have this dA. dA will be dx dy, or you can do polar if you want, and that's actually what we're going to do. Derivative of z with respect to x, and you have to fit now the square root. I will put a square root at the denominator. 2 goes to the denominator. 16 minus x squared minus y squared, and minus 2x to the top. You don't have to, but it takes less space to write down. Yeah, I want to do it next time. Next step, so people don't feel awkward later, like where did it go? 2 is outside. And then we have 16 minus x squared minus y squared, like so. Bless you. So ugly. Like so. Still want to show you something, and now I cannot find where I saw it. Something really awesome. First of all, let me ask if you agree with this. What do you think? And now the questions. Yes.
Yeah, 2 things. The first is like, can you just repeat like how you knew for like the function f to use the one with the 16 and not the other one?
Surface area.
And then the other thing is, where did you get the inequality sign?
The inequality is for the 8, less than or equal 8.
Yeah, how did you know that?
Oh yeah, this one is easy to explain than the other one, so I'll start with that one. I saw such a good picture to explain that, and now I cannot. So weird. So I saw it here. I guess you're right. I should not skip the steps. Can anyone explain where did I found the z equals both ones? Like where did they come from? Because I kind of skipped the step and now it's not very clear. Where did the z come from? Yes?
The equation was given as x squared plus y squared plus z squared equals 16, and you solved for z.
So this is my sphere, and I will do like this. From here, find z equals. Right. And then this one luckily was already given as z equals, and we knew it is not negative, right? Is it?
Like I know how you solve for z,
Oh.
but like how did you get the less than?
Oh, the inequality. Let's see. So when I solved at the very end, it was 2 equals to 16, and divided by 2, I got 8. That is a circle. The circle is the biggest line of the shade, but I need all of it, not just the outside. So to make it filled, yes, that's what you call a disk, to make it filled, I need to understand that it should be less or equal than the radius, which is square root of 8 squared, right? So then this will be also included, which is, say, 3, radius 3, radius 2, radius 1. So all of them will be included, and I need that, or else if I don't, I only end up with this beautiful side of the ice cream. Yeah. Yes, I will answer the second one second. Yes.
So, how do you know in the step 2 that we are using exactly the z equals?
Yeah, that's the same question here. Good job. So I will say, because it's on the top, but somehow I just realized that I am hesitating to say that for some reason. Yes?
It's because the question asks for it. Like it asks for the surface area of this part of the sphere instead of.
Oh, that is of the part of this duh. Thank you.
I was like really confused.
I just like, I remember it's on the top, but I feel like it's not a good answer. Why did we know? Thank you. Okay, yes. That's, see, I was like, I'm pretty sure it's not hard to answer. Okay, see, very good, very good. Surface area of the sphere, that's why. Duh. So if you need the difference, then you would do the difference, as we always do top minus the bottom, right minus left. If you need the cone, you do the cone, but in this case, they actually said it. I'm like, I remember it was on the top, that's why I chose it. No, it is true, but also because they said so. Yeah, thank you for asking. Let's write it down somewhere, or else the notes are not clear. Step 2. Use sphere. Sphere because they asked for sphere. They asked. Because they asked. Yeah, the problem basically is asking. So we're not finding the surface area of the whole ice cream. See, I mentioned at the beginning and now it became confusing. So that's my fault. Yeah. Should not say that. So this is the important step right now. This is the, do you guys understand, or I made it more confusing than it should be? Step 1, find the intersection to find a domain. Domain, we found a circle, but we don't need a circle. We need everything before the circle too, so that became a disk. Disk is when you have less or equal the radius. Step 2, choose the function. We chose the sphere because they asked for the surface area of the sphere. Step 3, find partial derivatives. Step 4, well, I call step 3, write down the formula. Here's the formula. Does that make sense? Can you do it on the test? And actually solve it. So one important thing is missing is this d and dA. We know that this d is x squared plus y squared less or equal than 8. That's what d is. So now we have a choice what coordinate system to use to actually write down the double integral part. So it's going to be like this. Integral, integral, still a huge square root. It simplifies nicely, believe it or not. X squared plus y squared cancels out a little bit here and there, plus 1, I can see it. It becomes 16? Yeah. Becomes 16 all over 16. No, there's no square root here. All over 16 minus x squared minus y squared, like so. 2 cancels out with 2. And you have x squared plus y squared, and then square roots go away because we're squaring them. Common denominator shows up, blah, blah, blah. X squared plus y squared. Oh, I see. That is actually not very obvious how they made it. I guess that should show you, or else it's not fair. We'll have 1 plus x squared plus y squared. It's just not interesting, so I don't want to do that, but let's do that. I mean, this is, the tiny calculations is the most boring part, I think, but this is where people stuck at the homework, so I should show it. So this is what we have when we're squaring each side or each derivative. Now we have common denominator. So I guess let's keep dA, and we have d double integral a square root. And I have common denominator 16 minus x squared minus y squared. 1 is 16 minus x squared minus y squared plus x squared plus y squared. So x squared and minus x squared, y squared and minus y squared cancel out, and that's how you get 16. Square root is there. 16 all over 16 minus x squared minus y squared. Don't write the a because now it's time to change. What do you think? Like that's algebraic. I don't like showing it, but here it is. Here you go. So what's important is, why did we teach you so many coordinate systems? Who cares? Yeah, this is where you care. So this is where you actually need to figure out what to do, which coordinate system to choose to integrate over D, and D is a disk. You can do dx, dy. So pay attention right now if you like zone out. Oh, just a second. You can do dx, dy, and you will do dx from like minus the square root to square root, dy from minus square root of 8 to square root of 8. That is because radius is square root of 8. You can do that. Or you can do polar. You choose dr, d theta, blah, blah, blah. So that's why we gave you so many, so you can actually make a choice here. Yes? Oh, thank you for asking. This is 16 minus x squared minus y squared over 16 minus x squared minus y squared. And then you create common denominator, right? So over 16 minus x squared minus y squared over 16 minus x squared minus y squared. And then you merge them together. Least common denominator. Yeah, right? LCD? Sounds like a drug, but okay. Yes?
If you integrated in polar, do you put r before the dx?
Amazing. You're kind of one step ahead. I was supposed to ask that question. Okay, forget what he just said. Choose your character. Choose your boss. Do you want to do polar or you want to do Cartesian? Polar. Why? Because it's a circle. So you have this intuition. It's not because this book tells you, and it's not because all the circles were done in polar. Because it will be harder to do it in Cartesian. It just makes sense. Everything that spins, do it in polar. In 3D, it spins differently. If it spins but still flat, that's cylinder. If it spins and it's very circular, there's no lines, that's spherical, and so on. So let's do polar. But polar has a formula. The tail has a special formula, which is r dr d theta. Yay! See, how cool is that? And now it's so hard to create polar limits of integration. I don't know if you can handle that. What r is changing from? 0 squared of 8. Wow, that was fast. And theta? 0 to 2 pi. See how cool is that? So that is much better than the square root and not the square root. But I'm just going to mention the problem in a second. Let me show again to everyone who now is upset why everyone knows how to do it. So those who are upset, check it out. Theta is running around, so it's 2 pi. That's how we know. There's no angle, there's no patches, like it's going the full circle. Theta into D. And r, why is not from minus square root of 8 to square root of 8? Because r is a distance from a center. So it goes like that, or like here, or like here. And it's changing from 0 to square root of 8. Why square root of 8? Because that's what is the radius of the circle. What did you want to say?
Yeah, so it's not 16 minus x squared minus y squared.
That's a problem. We're not supposed to have x and y if we're changing. So you have to change everything. Let's do that. There's only one piece to change. This is minus parentheses x squared plus y squared, which is r squared. Amazing. So you see, you became very good at this, and you should feel proud. 0. Square root, actually 16, okay, it's fine. 16 over 16 minus r squared, and then r squared outside, right, of the square root. And then, no, just r, dr, d theta. Is this correct? Okay, good. But then square root of 16 is actually just 4, so you don't have to have the whole thing. And you can put 4r together, so that's also, why not to do that, and so on. And then you integrate. Keep going. So I will have 4 outside, integral r at the top, square root of 16 minus r squared dr d theta. Just some quick manipulation. And now, because all limits of integration have numbers, just like you said, we can split it into 2. Everything with r, step to the left. Okay. r 16 minus r squared dr. Everything with theta, step to the right. Nothing, d theta, from 0 to 2 pi. Remember, it's not plus. 3 people in the test put plus instead of times. I know, it's hard to remember. But just remember that there's no plus here, so it's assumed to be product. Times. Bless you. Also, you should know from logical point of view, from logic, plus means or, times means and. So what I'm talking about here, this is happening and this is happening, not or. That's how it might help you to remember. Yes. To square root here of 8. Okay, so this one is easy. What's the answer for this one? 2 pi. I should say second integral is 2 pi. And then the first one, how would you proceed?
U sub.
Yes. Your favorite, U sub. I asked my senior and junior students, who I did not teach for 2 years already, do they remember U sub? They're like, I did not use it for ages. Anyway, but it's important. It is everywhere. I should have asked you what to choose. Du will be minus 2r, dr, blah, blah, blah. So I will skip that. U sub, and you get the answer, 32 pi, 1 minus 1 over square root of 2. That is the example when you are given z. So, note, we used the second formula because z equals f of stuff x comma y was given. It was given explicitly, so that speed up the process. In the previous example, we had to find cross product, so to be honest, I checked at home. If you parametrize and you find the cross product, the answer will be the same. Questions about this? What do you think about that stuff? Yes?
Something like this can come up from the final.
Yeah, for sure. New material comes to the final. Oh, you mean the second formula?
I mean, such a long integral. It's not that easy to do.
Oh, remember the last integrals you can do in your calculator, but I agree with what you're saying. I just received final, so I did not look through. I looked through, I did not like it, so that's what I know. So I will try to make it faster. Yeah, but it's hard. For calculus 3, it's hard to make it fast. Lots of stuff happening. Questions about this? There was a question if this is going to be so long on a test. I'll try to make it faster. In general, I agree with your logic. Calculus 3, not supposed to check use substitution integration by parts anymore. I want to see that you can build triple, double integrals and work with them. And you know the formulas. So, no, it's a good point.